Hello and welcome to today's webinar, Getting Started with AWS Device Farm. On your screen, you will see a Q&A pod on the right-hand side of your screen. Please submit your questions for our presenters and moderators at any time today, and we will address them as they come in. At the conclusion of today's presentation, there will be several poll questions preceding the Q&A. You'll find those poll questions on the left-hand side of your screen, and if you could fill that out and give us feedback, we really do appreciate that. And again, thanks for joining in today. Today's webinar is being recorded. In the next few days, we will send you a follow-up email with the on-demand links to the presentation deck and the webinar recording. And again, I'd like to welcome everybody to our webinar, Getting Started with AWS Device Farm. Our presenter today is Trent Peterson. Trent is a project manager for AWS Device Farm, a mobile app testing platform that helps developers automatically test their apps on hundreds of real devices in minutes, and catching issues before they're released into the wild. He joined AWS through the acquisition of AppTwack, an app testing company he co-founded. Prior to AppTwack, he was at Intel designing system automation solutions, trusted to test products used by millions of customers with an emphasis on simplicity and user experience. Today with us, we also have Paweł Wojnarowicz, Nikhil Dabota, and Andrew Hawker. They are our webinar moderators today, and they will be engaging you with your questions and answers in the Q&A pod. At this time, Trent, welcome to the session, and the floor is now yours.
Thanks, Jerry, and thanks to all of you for joining us today to learn more about Device Farm and how to test your mobile applications. So before we get started, I want to walk through sort of why we built Device Farm. So as you're likely well aware, as application developers, consumers have a very loud voice and can sort of make or break your mobile application's success within the markets. So when an application doesn't work, the first order of business is to essentially let the developer know or let everybody else know by way of reviews in the various markets. And now, why do they leave these reviews? And so the question can be answered by the fact that there are many variables and variations that make it extremely complex as an application developer. So essentially, it's very frustrating for a consumer because they expect an application to work on their phone, their tablet, their television, across all the myriad devices that they might have. And it's frustrating from a developer standpoint because you have to deal with all of these devices. And I'm not just talking about the fact that there are thousands upon thousands of different screen resolutions, CPUs, GPUs, and so on, but also the fact that we have carriers making modifications, we have manufacturers making modifications, we have different stacks of hardware. We also have environmental factors. So our end users might be, with inconsistent connectivity, but to them, they don't know that that's what's causing their problems. It's always the app is sort of the first stop for the blame, and that affects, of course, your application's placement in the market. And so it's frustrating all around. And so that's why we built Device Farm. And as a developer, you're probably also used to collecting hardware and testing on various devices, and you well know that every shop that you go into pretty much has a cabinet or a desk, or even if it's a large company, rooms upon rooms of these devices available for testing by developers. It's extremely expensive, one, to collect that hardware, and that's just the start. You also have to wire all of those devices up, keep them charged, keep them up to date, maintain their stability, and then also if you want to actually run test automation in a scalable fashion, you have to build that automation infrastructure. And so developers were telling us that this was a very large pain point for them, and this motivated us to build Device Farm. So what to expect in today's webinar? We'll start with an overview of what Device Farm is and what its capabilities are and a brief history of the service. Then we'll go into a demo, so you don't just take my word for it. We actually will walk through scheduling a test and interpreting a report. We'll talk a little bit about how to integrate Device Farm into your development workflow and continuous integration setups, including a demo where we'll launch a test straight from Jenkins CI environment. And finally, we will wrap up with Q&A, where you can ask any questions that you might have. And of course, you can ask questions throughout the presentation, and the moderators will help answer those, and I will answer some at the end. So at its core, AWS Device Farm enables you to test your mobile applications on real physical phones and tablets in the AWS Cloud. So these are not emulators, these are not simulators, these are real deal hardware, the same exact hardware that you're carrying around, your users are carrying around, that you buy in the store. We support testing on both Android and iOS platforms. The application types can be native, hybrid, or web. So whether you're building your application using Xcode or Android Studio, or you're using a framework like Xamarin or Unity, or you're building a web application that loads in the mobile browser, you can test your applications with Device Farm. Now, I mentioned that we have real physical hardware. So we have hundreds of unique devices that you can choose from. So when I say a unique device, I refer to the make, the model, and the operating system version that's running on it. And when we do the demonstration, I'll point this out as we're selecting devices. Now, behind each of those devices that you can choose from, we actually have many instances of each so that those devices are available to you for your tests when you need them. AWS Device Farm is designed from the ground up with security in mind. So we have a couple main points here. One is that on the hardware side, the devices are actually physically isolated. So you may be familiar with devices laying on tables or in racks side by side. Our devices are physically isolated from one another, and this means a couple of things. It means that the devices can't see each other, so there's no way for one phone to take a picture or a video or an audio recording of a device next to it. And then also it means that the devices can't see each other from a wireless standpoint, so Bluetooth traffic, Wi-Fi traffic, and so on. On the software side, the devices are dynamically tethered to a host machine, so when you run your tests, it runs on a host machine that has the device plugged into it over USB. That host machine that executes your code is brought up on the fly, runs your code, and then is torn down. It is not reused between customers, so you can be sure that your test code and your application are running on fresh hardware, fresh images and fresh hardware. One more note on the security side is that when your application is done being tested, we uninstall the application, we reset a number of settings on the device, we do a number of verification steps, and if any of those fail and we cannot verify that your IP was removed from the device, we will quarantine the device and a technician will attend to that device. If we still cannot recover the device, it will be destroyed. Next up is flexibility. So our devices are exposed for two primary use cases. First, you can perform manual testing. So with our remote access feature, you can select a device, get a window to that device's screen right from within your browser, gesture, touch, and manipulate that screen, upload applications, and perform manual tests, reproduce customer issues, and so on. And then at the end, you'll get a video recording of that session along with the logs. Now, as I mentioned before, because there are so many devices out there, manual testing is simply not scalable. So that's where automation comes into play. So if you've written automated tests for your application, or even if you don't have automated tests written, we have a built-in feature that allows you to run automated tests without any scripting. You are able to run those automated tests that you've written or our automated tests for your application on many devices in parallel. So you can select one device, you can select 100 devices, and then we will fan that test execution out across those devices and then create an aggregate report that includes screenshots, performance data, logs, and video. And those reports are available through our console interface, and we'll walk through that in the demo. Those reports are also available through our APIs, which we'll get into in a little bit. So about integration, again, we're going to go into a demo later in the presentation where we'll launch a test straight from Jenkins. We have official plugins for Jenkins and Android Studio and Gradle. And then through our SDKs and CLI, you can access our API. And so everything that I show you today within our console, it's important to note that everything you see is available through our API, including the reports as I mentioned before. And it's also important to note that when you look at those reports and you see the layout and all of the results and videos and screenshots, that our API actually allows very granular access to this, so you can programmatically pull just the bits and pieces that you want through that API. So a little bit about pricing. So unlimited testing starts at $250 per month. And this is based on test concurrency. We call them device slots. So you can purchase, let's say you purchase 5 Android automated device slots. You select 10 devices to run your tests on. It will simply run 5 at a time. So it would run 5 and then 5. You would get your report, your full report back. And that would be billed at $250 per slot. So in that case, $1,250 per month. And you can run as much as you'd like throughout the month, schedule as many runs in parallel as you'd like. It's simply going to limit the number of devices that will execute tests to the number of slots you have for the relevant type. We also offer a pay-as-you-go model. So with no commitments, no upfront charges, you simply pay for the device minutes that you use. So for instance, if you run 5 devices, your tests take 5 minutes, you'd be charged for 25 device minutes at 17 cents per device minute. And after today's session, I encourage you to give it a try. Your first 250 minutes on AWS Device Farm are completely free. Availability. So we'll talk a little bit about where to find Device Farm. So the service was launched in July of 2015. And it's in the US West region, although it's important to note that it's available globally, and we have customers from around the world running tests on us 24/7, and that, again, that the devices, like I mentioned before, are real. They're hosted in the US, but they are not all US devices. So for instance, we recently deployed a number of India market devices to our fleet. And you can find Device Farm in the console under the mobile services section. Simply go to the console, click on the icon, and you'll be walked through a getting started guide so you can be up and running with Device Farm. Now before we get into the demo, I would like to talk real quick about high-level use cases that we've seen developers using Device Farm for. So using things like our Android Studio plugin or our CLI and integrating with local development environments, testing iterative changes during development. This also includes using remote access to verify functionality on manually exercising a piece of functionality that perhaps tests don't exist yet for. So testing those iterative changes. We also see developers testing cumulative builds. So through CI plugins like Jenkins, we see tests coming through perhaps on a nightly build. Some are based on commit. So as soon as something gets pushed back into, for instance, mainline, a build is created and tests are executed automatically. And then we see developers that test and verify functionality just prior to release. So maybe automation isn't as mature quite yet for some developers. And so this gives them a chance to just run some basic smoke and validation tests just before release on a large number of devices, so they can be sure that there's no obvious gotchas within their application, and they don't have to find out the hard way through their end users. We also see developers using the service to monitor their released applications. So for instance, running tests periodically throughout the day, every single day, exercising basic functionality that hits their backend. And if something goes wrong, for instance, if something goes wrong more than a couple canary runs in a row, they can flag this as something to look and investigate because it means that there might be an outage out in the wild. And finally, reproducing issues reported by analytics and end users. So you might get a report from a customer, they might call in, they might walk you through, here's the device I'm running, here's the operating system, this is what's happening. We see developers using our remote access feature to grab a device that mirrors the device that the customer is using and follow their steps and reproduce issues so that they can quickly debug them without actually having to purchase and acquire the hardware and use it locally. And with that, I'm going to jump over to a demo of Device Farm. Okay, so now we're looking at the project list within Device Farm. So I'm going to walk you through the main concepts within the service, and we'll go ahead and schedule some tests and interact with the reports so you can get a feel for what is possible for you to help you debug and solve issues within your mobile applications through Device Farm. So in Device Farm, the first high-level entity is a project, and a project can be thought of as it's a generic workspace that allows you to organize your test results, your device pools, which is a concept that I'll get into in a few minutes, and your files, and sort of group those. And so we see some developers use projects for instance, a specific title. So a title just for Android, they'll have a project. The title for iOS, they'll have another project. Some will use the same project for both iOS and Android applications. Further, some will use the projects to differentiate between nightly builds and regression tests and so on. It's completely up to you. So go ahead and hop into a project that I created for today's webinar. And I mentioned before that there are two main use cases, automated testing and remote access. So before we jump into automated tests, I'll go ahead and schedule a remote access run. So this is where you can manually manipulate a device and reproduce customer issues. So the first step is to choose a device. And you can see that we have a number of iOS and Android devices. I'll go ahead and select, in this demo, the HTC One M8. Go ahead and confirm and start the session. And then, as I mentioned before, what will happen is that we go out to our physical devices in the fleet, we find an available device that matches the device we've requested, and if you noticed, first it said that we were finding a device, and now we're setting up the device. So it was within seconds, it found a device that matched our request. That device is now being prepared, and that preparation takes up to a couple minutes, and what we're doing there is we are verifying that the device is in a state ready for your session. So we do a number of validation steps just before it's released to you, so you can be sure that the device is healthy when you receive it. Now, while we wait, we can actually go back over, and we can see that our session that I requested is still being prepared. While that's going, let's go ahead and schedule an automated test run as well. So I'll walk you through that. So the first step in an automated run is to choose an application. So I'll select Android and iOS as my application type. And then I have the option to upload my application or select an application that I previously uploaded. And you can see I have an iOS application, a .ipa, and an Android application, a .apk file. I can also go ahead and upload a new build of my application, which is what I will do. And while that's uploading, a quick note about these files that you submit, there's no instrumentation necessary on these binaries. So you simply take your application binary, upload it to us as is. This could be the same binary that you push out to beta testers that you use to test locally, or even the application that you submit to the market. And this goes for both Android and iOS applications. And on the iOS side, there's no need to whitelist our devices or add our devices or do anything of that sort. You simply take your binary IPA, upload it to us, and we'll take care of the rest. Okay, and so now once our application has been uploaded, we show some metadata that we've parsed out about it. And the second step is to configure the test that you want to run. So I mentioned before that we have a number of different automation frameworks that we support, including a couple built-in frameworks that do not require any automated scripting on your behalf. So we have an Explorer and a fuzz test. The Explorer will crawl your application in an intelligent manner. So if it finds a menu, it knows to open the menu. It'll click an item, and it explores the application, and it knows how to back its way back. It knows how to avoid getting stuck in a loop. And it will take screenshots and video of the entire session. You can think of it as a naive user. It's not going to exercise the business logic of your app, but it is pretty good at getting through the majority of the screens within your application. We also have a fuzz test that's built in, again, no scripting necessary, that's going to hit the application with random user input in a really, really rapid fashion, and you have a few controls that you can manipulate here. But it's just, if you're familiar with Chaos Monkey or monkey testing, that's what we have here. Now, if you've written tests for your application that exercise specific business logic, take screenshots and so on, We support a number of frameworks, and you can see those here. A few flavors of Appium, Calabash, instrumentation, and UI Automator. For today's demo, I've written instrumentation tests, actually written in Espresso. So instrumentation includes JUnit, Robotium, and Espresso. And again, I can select an application test package that I have previously uploaded, or just upload a new version of my tests. And similar to the application that we uploaded, the tests here do not need to be instrumented or modified in any way to run on Device Farm. So you're not using a library that we've written, you're not writing code that locks you into Device Farm. These are the same tests you would run locally. One thing to maybe note there that we see a lot of developers struggle with is that when you go from your local environment, maybe testing on emulators, simulators, and maybe a handful of devices, when you scale that out to potentially hundreds of different hardware makes and models, we see people struggle with dealing with that sort of more hostile environment where device hardware might be more finicky, it might not behave the way you expect. We see timeout issues and so on. So it's really important that when you're writing your code, even to run locally, that it's written in a very defensive manner so as to adapt to the various device profiles that are out there. Okay, so once we've uploaded our test, we'll go ahead and go to the next step, which is to select the devices. So by default, it's selected a curated pool called top devices. And you can see that it contains about 5 devices, and we're compatible with every single one. If your application, for instance, said that it didn't work on a specific API level and down, then if you had devices in the pool selected, you would see a message saying that your tests are not going to run on those devices because your application is not supported. Now, in addition to that curated pool, we can create a new device pool. And there are a couple ways to create a new device pool. One is to use a rule. So for instance, you could say, I'm only interested in Samsung devices. And when we look at Samsung devices down here, we can see that they've all been selected. Go ahead and clear that rule. So that's one way you can create a device pool. And the power there is that if you create it with rules, those rules are applied dynamically whenever you make a run, schedule a run on this pool. So as we're adding devices to the fleet and making them available, which we do on a weekly basis, your pool will actually grow and adapt to the fleet as it exists at the time of your run being scheduled. So if you're always interested in testing on all tablets, you can simply add a rule that says to test on tablets, and anytime we add a new tablet, it will automatically be included in your device pool. Now you can also explicitly select devices and create pools that way. So if you have analytics and you know that these 10 devices are the most popular devices amongst your customers, you can create a pool for that, and then you can modify that pool over time and keep it up to date, and then reuse that pool whenever you schedule a run. For today's demo, I'm going to go ahead and leave it on the curated pool that it selected, the top devices pool. And the final step before we start running our tests is to configure the device's state and environment. So here you can upload extra data, and this allows you to upload a zip file containing arbitrary data. So if your tests or application consume media like like images or video or music or anything like that, you can do that here. Also, if you have test configuration data or some sort of database, you can upload that here as well. And on Android, we will unzip this to external storage, and on iOS, we will unzip it, we place it inside of your application sandbox. In addition to that extra data, you can install other applications. So this allows you to install dependencies of your application. Maybe you have applications that your app can integrate with. And finally, you can actually test upgrade flows through this piece of functionality. So you upload the old version of your app here, you uploaded your new version in that step 1, and then you actually test an upgrade flow through your app. You can upload one or more applications and select the order in which they're going to be installed as well. Next up is setting the radio states. So you can dictate when, what the state of the radios will be when your application is launched for the first time. So for instance, you can disable Wi-Fi to see how your application will respond without any internet connectivity on first launch. And then to test things like geofencing and location-based services, you can specify the device's location by latitude and longitude. So the devices are, of course, in AWS data centers, but you can simulate that they are anywhere in the world by specifying the latitude and longitude. And then finally, you can test localization functionality by specifying the language and dialect that will be set on the device to see how your app will display when it's used in whichever market your app happens to find itself. And once we are ready to go and we've reviewed that everything looks to be in order, which it does, we'll go ahead and confirm and start the run. And so we can see that it's in the scheduling state, that the run, and when I say run, it refers to a build of our application, a test package, those tests configuration, and the device's configuration. And then once it's done running, the report that goes along with it. That's all considered a run in Device Farm. And a run has a report that we'll explore here in a second. So we can see that the run has started executing, and it looks like it's already picked up all 5 devices that we scheduled on. So as those devices finish executing tests, you'll be able to review the results here. We do not make you wait until all tests on all devices have finished to see your report. It's built dynamically as results come in, so there's no need to wait. If something comes back and it looks a little weird or funky and you want to investigate it, you can always stop the run. We'll kill the execution on any device that's not completed, and then you still get a partial report there that you can investigate. So while that's running, let's go ahead and switch back over and see how our remote session is doing. So if you recall, we started a remote session on the 1M8, and here you can see that we have a window to the device. And through the browser, I'm able to gesture and swipe and use the device as if it was here on my desk or in my hand. Over here on the right side, we can install an application. So I went ahead and selected an application to install. As soon as that application is done installing, we'll be able to find it in the app tray. And run our tests and simulate whatever it is that we're looking to do on the device. And now, as I mentioned before, you can also do things like switching to landscape. Actually open it. So you can see here that we've switched it to landscape mode now. So you can manipulate the device, install applications, gesture, and so on. And then once you're done using the device, actually, before we do that, let's see if our application is installed. It doesn't look like it's installed quite yet. So once you're done with your session, you can go ahead and click Stop Session. And Stop Session ends the session, and then once it's completely taken down and we're able to pull the results from the device, you're going to see a video and you're going to see logs here. And we can take a look at that here in a second. So going back over here to the automated run, let's actually look at what a report looks like. These tests that I uploaded take about 20 minutes to run, so I don't think I won't make you wait here for those to complete before we take a look. But I have a project from a previous session that we can look at. And so here is a previous session that we ran, and here you can see that the run is completed. You can see the test results, so pass and fail. If I click on that run, I can see how many tests passed, how many tests failed, and so on. Now, the first thing that you see below this is unique failures. And so, as you can see, 21 tests failed, but only 13 of them were unique. So for instance, this first failure message occurred 6 times. And the idea here is that we parse out the common failures and group them so that you can solve the issue likely in one spot and solve it for all of the places where it occurred. And of course, you can click on one of these problems and it brings you straight to the test where the issue occurred. And you can see exactly where the problem occurred, complete with logs, which on Android is the logcat, and on iOS would be the device's logs. So going back up to that summary view. So again, unique failures at the top. Next up is a list of all of the devices that ran tests. So for instance, let's take a look at the LG G-Pad here. It looks like it had one failure. So you'll notice that as I progress through the report, we become more and more granular, but the types of data that we're displaying remains the same. So right now we're looking at the LG G-Pad. You can see that we have details, screenshots, performance data, and files. Now within a device we have the concept of a suite, and you can see that there are a number of suites here. Some have varying numbers of tests. So let's go ahead and pick one. And so now we've clicked on a suite, and now you can see that we're, on the LG G-Pad still. We're now within this suite. Within this suite, we had two tests, Test Sanity and Test Radio. Again, you can see logs down here, but now these logs are scoped just to these two tests. And then I can go one step further and click on the test, and now we're looking at a specific test within this suite on this device. And again, now logs are going to be scoped just to this particular this particular test within this suite within this device. We have a screenshots tab, so you can go over here and see any screenshots you may have triggered. Now, if you're using our built-in tests, we automatically grab screenshots. If you're using your own tests written in one of the frameworks we support, most of them have a method for you to take screenshots, and we have that in our documentation, which will be linked in a follow-up to the webinar. So you can actually trigger exactly when you want a screenshot, and we'll take care of that, pulling those from the devices and putting them into your report for you. Next up is performance data. So we're tracking CPU, memory usage, and thread counts, and you can see that here. It's sampled every couple seconds, and as you back your way through the report and become less and less granular or more and more granular, this performance data is going to be scoped to the area of the report that you're looking at. And finally, we have files. So I mentioned before that we show you logcat right there in the console. You can also download this file for your own local analysis. We also, depending on the framework you've supported, have a number of file types that we allow you to download. So in this case, since we ran an instrumentation test, we have instrumentation output from the test. And we also have a video here. And so if I click on the video, play, we can actually watch a playback of how this test looked when it executed on this specific device. And that video is automatically captured for you. So you don't have to do anything. You don't have to instrument in any way. You don't have to trigger the video. We automatically capture it for every single test that you run on Device Farm. And I mentioned before that on remote access, for the session, when you're done running that session, we produce a number of files. So for instance, in this case, we have a video of our remote access session that we ran. In this case, it was on an iPhone 5C. Similar to the automated run we were looking at, you have full access to logs here, including, in this case, it's the device's logs. Since we're looking at iOS, on Android, it would be logcat. And we can see here that we have a video of our entire session. We didn't do anything very interesting in it, but you have that video. So for instance, if you reproduce a customer issue using remote access, and now you want to take that and submit it, maybe attach it to a JIRA issue or some other ticket or bug tracking system that you might have, you can do that. You can not just screenshots, but also that video to show exactly the steps that were taken to produce the issue. Okay, and with that, I will hop back over to the presentation. So next I want to talk just for a few minutes about continuous integration. So as I mentioned before, and in the demonstration, we went through the AWS console. So you can schedule tests, hook things up, manage device pools, upload and manage your files, and so on, and view results through the console. Now, it's very common to not want to necessarily go to the console. If you're running tests every single day, maybe every hour, you're not going to go to the console and schedule tests multiple times per day. So we support 2 official plugins, one for Jenkins and one for Gradle, which allows you to run tests straight from Android Studio. We also have a CLI, so you can manage and control Device Farm and use Device Farm straight from the terminal. And finally, we're included in the AWS SDKs, languages like Python and Ruby, .NET, JavaScript, and so on. So you can use Device Farm from whatever environment that you're comfortable with. So you can kick off tests, you can pull down results, and so on. So we'll hop back over to the demo, and I will show you how to schedule a test in Jenkins. Okay, so now if you're familiar with Jenkins, this is a local instance that I have configured, and I have a project inside of here called my Android app. Now if we look at my Android app, I have it configured already to run tests on Device Farm. So we can see here that we have a number of previously run builds. So we can see how many tests passed, failed, warned, and so on Device Farm straight from within Jenkins. We also have a link to view a full report that will open a report in the AWS console. So you can analyze the results and reports in a graphical way. The plugin also has a feature to automatically pull down all of the test artifacts, so things like screenshots and video files and so on. It will automatically pull all of that down, so you can archive it locally if you desire. So a quick note on configuring the plugin. So the plugin allows you to configure Device Farm as a build step, and you simply specify the project, the device pool that you would like to target, where it can find your application, for instance, where is your binary, where's your build output going to be, the naming pattern for the run, a number of other parameters, things like storing test results, which I mentioned, so it will automatically pull down the test data, screenshots. And then finally, you configure the type of test you're going to run. And in this case, similar to the demo, it's already configured to run an instrumentation test. I simply put in a pattern to find that file. So we'll go ahead and kick off a build. In this case, I have it wired up so that I can manually trigger a build. So we've scheduled the build, and we can see it here. And now if we go over to Device Farm, and I go to relevant project, we can actually see that now we have a Jenkins scheduled run awaiting execution on Device Farm, and you can see it already picked up some devices. So now if we go back to the project, you can actually see this is the run that we scheduled manually through the console here, and here is the run that we just scheduled through Jenkins. So they're both going to show up here in the console as well as in your Jenkins environment. And then again, as those results are pulled in, you'll see a new row show up here right inside of your Jenkins environment that shows those test results and has a link to view its report. Okay, and now we'll switch back over to the presentation. Okay. Good to go. Okay. Okay, so that was a demonstration of Jenkins. And before we jump into Q&A here, I just want to sort of recap. So we walked through the overview of Device Farm, we talked through and demonstrated how to schedule your tests in the console. We talked about integration and how to schedule tests through Jenkins. And then we have a number of links here that are helpful. For instance, we have samples. So the application that I was using in today's demonstration, along with the tests that go with it, are open source and available on GitHub. We also have a community forum so that you can ask questions and interact with other developers that are running tests on Device Farm. We have a direct line for you to reach out to us if you have any questions or need any help. And now we will open it up to Q&A.
All right, and thank you, Trent. Thanks for the great presentation. And I want to thank Powell, Nikhil, and Andrew for engaging the audience through the Q&A panel. So on your screen on the left-hand side, you're going to see 3 polls. Please go ahead and complete those. That'll give us feedback for our session. The feedback's very important to us, so thanks for taking the time to do that. We do have some time left, so we're going to run through some more Q&A questions. So at the top of the slide there, top of your screen, you should see the Q&A panel. Feel free to enter more questions in there. And again, as Trent mentioned on the slide at the bottom, there are some links you can grab there as you go through that. So Trent, I'll go ahead and turn it over to you for the Q&A session.
Just a moment here, we're pulling up the questions. Okay, so the first question here is if we test on a pool of 5 devices, does that mean you'd be paying for 5 device slots? And so the concept of the device slot is concurrency, not specific devices. So for instance, you could purchase a single slot for $250 per month, schedule on 5 Android devices, and it would simply run in a serial fashion, one device after another until all 5 devices had executed your tests. So you're not going to be charged for 5 devices, it's just one slot. If you were to buy 5 slots and select 5 devices, then it would run on up to 5 devices at a time. There's another question here about whether or not we support Apple Watch and Apple TV and other non-phone and tablet items. The answer is not today. Today the focus is on phones and tablets. However, we of course listen to feedback and we've heard the ask before for other forms of hardware. If you are developing applications for accessories or you're developing applications for non-phones and non-tablets, for instance televisions, that's a topic that we would love to talk to you more about. So if you follow up with us after the session, we'd be happy to learn more about what it is you're building and how you are testing it and how Device Farm might be able to help. The next question is, using the Explorer, how does the test handle a login screen? So when you configure the Explorer, and this is the built-in test type, the Explorer, when you configure it before you schedule your run, you're able to input credentials for a username and a password, and then if the Explorer detects a login screen within your application, it will inject your credentials that you've supplied into the application, hopefully bypassing or logging in and moving on through your application. And then if you're wanting to test specific business logic within your app and you're writing your own tests, of course, then you can automate your own way through that login screen. There's a question here, and is there a way to simulate images or files uploaded to the device where an app expects it? So the way to do this is through that extra data feature that I mentioned. When you're creating a run, the final step is to add one of the steps there is to add extra data. This is an optional step that allows you to supply that zip file that contains arbitrary data. So if your application expects some data to be in some location, ideally you can upload it through the zip. On Android it goes onto external storage, on iOS into your sandbox. If it needs to be moved somewhere, you can do so through an automated test script. So you would actually write a script that would take that data from that location that it's unzipped to and move it to where it needs to be moved to. There's a question here on whether or not we support Appium. So the short answer is yes, we support Appium, but there are some caveats. So AWS Device Farm supports Appium in a server-side execution mode. What this means is you upload your entire Appium test package to us. We spin up the Appium components and we run your tests on your behalf against all of the devices you selected. So we don't give you a direct line of communication to run your Appium test. We don't give you an Appium endpoint to target at one of our devices. We do that all on our side. Now, the disadvantage here, I'll start with that, is that it means that you're running in our environment and not your local environment. So you need to understand the limitations or the configurations of our system, and we have that documented online. In most cases, it doesn't require you to do any modifications, but it is something to note. 2, it means that we do not support all flavors of Appium. So we support Appium Java Test and G, Appium Java JUnit, Appium Python, but we don't support things like Appium.NET or Appium Node, for instance, yet. So that kind of, those are the 2 disadvantages. Now the advantage and why we do it on the server side is that because we have full control over the entire Appium flow, we know when something goes wrong and we know exactly where it goes wrong, and we are also able to create an aggregate report across all of the devices you've selected. If we were to give you endpoints to all of the devices and you ran Appium against all of them locally, it would be on you to aggregate all of that data into a report, since we wouldn't have any insight into what's happening on your local machine. The next question is, because these are real devices, will I ever get into a situation where there are no devices for my test to run on? So as you likely saw in the demo when we scheduled tests, we had tests running on the exact same devices in parallel within seconds just from my account here, and that I was running against our production environment, the same devices that are exposed. Behind every physical instance, behind every instance of a device that you can choose from, we have many physical instances in our data centers, and we monitor this constantly for average wait times. And if a device looks like it's experiencing heavier traffic, we will actually deploy additional versions of that device to the fleet to address that. So the short answer is no. In most cases, the devices are available to you in minutes, if not seconds, of you requesting them. There's a question here on whether or not we support phones designed for Europe, and where can you find a list of supported devices. So we have a list of supported devices. The link that is on the page, up on the page, if you go to our aws.amazon.com/devicefarm page, there's a link there to view a full list of all of our devices. We have devices mostly from the North American markets. However, we've been adding devices for other markets recently, including China and India. And we are evaluating adding additional markets. So if there are specific markets, like for instance this question addresses Europe, if there are specific devices or markets that you would like to see added to Device Farm, please let us know. Because our device fleet, of course, we monitor and watch all the new devices that are coming out. But if there's a specific market that's of interest to you, then that's something we would want to know about, so we can consider adding those devices to the fleet. There's a question here on whether or not it's possible to not reset the device between runs. And so the answer is no, it is not. And the reason why is because the device, once your tests are done running on that device, the device is put back into the public pool where other developers can use it. Now before that happens, we uninstall the application, we do a number of reset steps. Now we do have a new feature called private devices that if you're interested in, it's single tenant hardware, and we can accommodate more use cases that involve not resetting the device, for instance, or putting static configurations on the device. If you're interested in that, please reach out to the email address that you see on the screen, and we'd be happy to have a conversation with you. Is it possible to add Google accounts to the devices? So it is not possible to programmatically add a Google account to a device. So doing this through automation is I wouldn't say impossible, very, very difficult. If you have a need for having a Google account on the device, I would again mention the private devices that I talked about just a second ago. And again, if you're interested in that, reach out to us. We do not recommend that you put a Google account on the devices. There's, again, this goes for any sort of sensitive information. the devices, the video is captured for every single thing that you do, and so even though you have full control over that video, it still means that you have a video showing your credentials being entered through a keyboard, likely in plain text. So something to consider. There's a question here on whether or not devices have the ability to connect to a Wi-Fi network, a captive. Oh, to a public Wi-Fi network. So the devices are contained in containers that do not allow them to connect to the outside world. So every single device has its own Wi-Fi connection that it uses to communicate to the internet. That Wi-Fi connection is just for the device that's in the container with it. And the IP is not public, so it's not possible to hit those devices from the outside world either. So again, the devices don't have carrier connections, they just have that Wi-Fi connection, and that Wi-Fi connection is just scoped to the device within that container. There's a question here on why to prefer real devices over emulators and simulators. And I don't think that that's necessarily the question that one should ask, right, is whether or not it's not an either or, it's likely both. And in most cases we see developers using a strategy that involves testing on both emulators, simulators, and real devices. And it comes down to the types of tests. If you're testing very, very small unit tests in an incremental fashion while you're developing, like, does this function still return true, for instance, then it probably doesn't make sense to run that on a real physical device, especially not lots of devices in parallel. If, however, you're implementing a new feature or piece of functionality or a new flow, especially if it concerns the user interface, an emulator or simulator is an approximation, especially on the performance side. So an emulator or simulator is not going to have the same CPU stack. It's not going to have the same Bluetooth stack. There are lots and lots of differences between the simulators and emulators and the actual real deal. And like I said, especially on the performance side. So, and then also carriers are making modifications, manufacturers are making modifications to the firmware. So again, your simulator or emulator is not necessarily a one-to-one mapping. Now, simulators and emulators, great for testing those small incremental changes like I mentioned, great for maybe a first run of tests on a new piece of feature or while you're developing your automation. But before you roll out to your customers who are using real devices, we've heard from developers that it's very important to make sure that their application actually works on that same hardware, not an approximation of that hardware. And then, is there a way to emulate separate software or hardware to connect with the device? So there is a way to do this in some cases, but it involves you doing the work, right? So it's mostly, can you mock it in the automation framework that you're using? If the answer is yes, then you should be able to run that on Device Farm. If the answer is no, for instance, if you're using a third-party accessory like a watch, it might be difficult to mock that device. We've also seen developers who run the device actually on a remote location, so maybe on your own local environment, and then have the device in Device Farm talk to it over the internet to facilitate their tests. And then there's a question here on whether or not we can send push notifications on a device. So on Android, the answer is yes, you can. On iOS, the answer is no, and it's due to the fact that we re-sign your application, and because we re-sign your application, it's going to break the push functionality, and that's something that we're looking at coming up with a solution. We're looking at coming up with a solution for that, and should have something soon. And then one other note on this is similar to the Google account question that came up earlier. If you use our private devices, then we can support this, this use case and do push notifications on the device. And then there's a question here on how long do you expect queue times for a device. And I think like I answered before, the devices, we monitor this queue time, and if wait times become excessive or devices are experiencing heavy traffic, when I say excessive, I'm talking more than, say, 15 minutes or so, then the devices will add new devices to the fleet to make up for that. And with that, I think we'll call it good. If you have any more questions, feel free to send us an email or go to the forums. We're happy to answer them. And thank you very much for attending today's session. I hope to see you test your applications on AWS Device Farm.
Thank you, Trent. I'd like to thank you for a great presentation today. And I'd like to also thank Powell, Nikhil, and Andrew for answering the questions in our Q&A panel. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS to cover in future webinars, please feel free to email to aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. Thank you for taking time to join our webinar today. At this time, you can disconnect. In the meantime, I am going to push out a link to you so you can see this open up on your screen. Remember, on the Q&A slide there, we also have some links for you from the session. So again, thanks for attending today. At this time, we'll conclude our session. Thank you and have a great day.